cooked up all of these evals today. So this will be the live demo part of it where we'll be walking through these. They will be like pretty fun to walk through. But welcome everybody to Archive Dives. Good to see you guys in person. We usually do this over Zoom on Fridays, so switching it up a little bit. And today we're not going over a specific paper, but we're going over small language models in general, because there's been so many small language model drops in the past month or so that I kind of wanted to put them to the test on some specific tasks. And so we're going to run through a couple evals, run through the specs of some of these small language models, specifically Gemma-3 from Google that came out, I think last week, and Mistral 3.1 small, which also came out last week. So that's the high level idea. And we'll make this like fun and interactive. And I have some like live chat demos and some live going through data demos. So feel free to interrupt me if you have any questions, or like if you want me to ask the language model something, we can do that live too. But before we dive into that, want to get a little like crowd survey. Who here uses LLMs? Pretty much everybody. This one might be a little more of a split, but who uses like the big foundation models from OpenAI, Gemini, making API calls? What about like local or self-hosted? So probably half now. How many people just kind of like send it and don't have evals for their for their stuff? They just kind of have a prompt that works. Yeah, I do that a lot too. Is anybody fine-tuning models? Cool. Yeah, I know you are. Awesome. Well, if you don't know me, I am the founder and CEO of Oxen AI. I've been training language models since they were just called language models and not large language models. So I was part of a company way back in the day that got acquired by IBM Watson when that was like the hot thing. And so our job was to take all of the things that went on Jeopardy and won Jeopardy and upgrade them to like a deep learning stack. So they had a bunch of like logistic regressions and maximum entropy models in there. And we had all of this hot new convolutional neural networks and recurrent neural networks. So we would rip out like their named entity extraction or their relationships or their sentiment and replace that with a deep neural network. Then left IBM and did like a bunch of consulting, just building AI apps for folks. And so I built in the computer vision space, NLP. I did like some 3D asset generation, done reinforcement learning. So I kind of have had my hands in a lot of different pots over the years. And that's why I really enjoy doing these archive dives, just like picking papers from a bunch of different domains and just seeing what the latest and greatest is. And I joke that one of my hobbies is looking at data, which is what Oxen is all about. So if you don't know what Oxen is, we're tools for collaborating on AI and ML data sets. You can kind of think of it as like a GitHub for machine learning data sets. And this is going to be the first time that I'm going to try this tab switching thing. See if it goes. Boom. This is what Oxen looks like. So it looks a lot like Git and GitHub, but you'll notice like we have 147 gigabytes of data in here. We have 1.2 million images. So this is like the type of data that you would never put into a Git repository itself. And then if you have structured data, like annotations on the images, those are first-class citizens within the UI rather than code. And you can do things like query it directly from the UI, edit it, run models, run notebooks, kind of like just a data science platform that looks a lot like Git and GitHub. But today we're talking about small LMs, which is going to be hard for me to say because I really want to say LLMs, but it's just small LMs. And there's a lot of benefits to small LMs. Running models on the edge, so just having something that can run locally on your Mac, or even like maybe if you have a device out in the wild, you could buy like a little Jetson, or some of these things can even run on Raspberry Pis, depending on how small they are. The models we're talking about today are kind of the sweet spot of 20 to 32 billion parameters, which is a really nice parameter count for a few reasons. One is you can run them at like full precision on a single GPU, so like an H100 or something like that. And then the quantized versions on the newer MacBooks that have like 32 gigabytes of unified RAM, you can download those and like run them with Ollama just locally. And I've done that on airplanes, for example, where I like don't have access to ChatGPT. I've actually wired that up to my editor to have like a little proxy to the local Ollama, which is kind of fun. But privacy is a huge use case for a lot of companies. Like they don't want to send their data to OpenAI or Anthropic. If you are in a really data intensive workflow, you might be optimizing for throughput or latency. We have the guys from Base 10 here who do a lot of work there. So if you're live and want to learn more about that, feel free to talk to Bola over here. They're fine tunable, so you can make it better on your own data, and we'll talk about that a little today. I think just the fact that they're decentralized is also cool. You don't have just like one centralized OpenAI or Anthropic like making the decisions of what the model should or should not be able to do. So small language models that you can fine tune help with that. And coding on an airplane is my last one. I also want to just bring up when I think not to use small models. I honestly think when you're like building your MVP or proof of concept, just use the best model that's out there. If the best model that's out there can't do it, then you probably aren't going to be able to do it with a small model anyways. And it's not until you get like real customers coming through and like real load of data that you even know what you might want to optimize a small model for. So you might as well just build it with like the biggest and best. If you need like broad knowledge in these, I would also say just use the big and best models. Complex reasoning tasks, I have an asterisk because I think the smaller models are getting better at this with some techniques, but that the jury's still out on that. And then as soon as you have like your data set and data flywheel set up, then I think it's a great time to start thinking about small models. So in the past couple of weeks, we've been seeing, oh, I see Attention Transformer raised his hand. I'll actually let you ask the question live.
Well, thank you very much. I thought your terminology of data flywheel was really interesting. Can you expand on that? Is it more than a data pipeline? Is there some kind of perpetual motion involved?
Yeah. So I use the term data flywheel, and I've seen this in just LLM work in general, where you'll have customer data coming in that's being run through your LLM, and you're constantly collecting that, constantly seeing where the model fails and where it succeeds, and then you're building up a data set of like successes and failures that eventually you could either turn into an eval or a training data set, train the next version of your model, then have more customer data come through, train the next version of your model. And that's kind of like the data flywheel. And honestly, what OpenAI did really well at the beginning is they just put GPT 3.5 out there and they're like, hey, play with it in our playground. They had a bunch of people playing it within their playground. They see what people are using it for. And then it got better and better. And they kind of got their lead by launching the model and running a lot of data through it. So that's what I mean there. Cool. Okay, so the motivation behind this talk is been seeing a lot of charts like this lately on X or Twitter, where a model will drop. This is one of the Quen models, QWQ32B, which is supposed to be a reasoning model. And on these, 5 different benchmarks, they are showing performance. QWQ is the red bar there, and then there's like DeepSeek is the blue, OpenAI O1 Mini is the gray. So a lot of the big models that tout that they have the best reasoning, and they're like, hey, QWQ32B is either on par or beats a lot of those bigger models on these benchmarks, at least. Same thing with Gemma-3 27B. They have this chart here that is the Chatbot arena elo scores. So this is like you have one prompt and then have two models output an answer, and people are voting on which model has the better answer. And they're saying out of all of these models up here, DeepSeek R1 has one of the better elo scores, but Gemma 3.27b is like right in second place there. And then these dots kind of on the bottom here are how many H100s you need to run those models. So Gemma 3.27b can be run on a single H100 versus like a DeepSeek R1, which has 671 billion parameters. You need a whole cluster of H100s to run. So like, if indeed this is true, that is a pretty substantial benefit of just being able to run it locally, and you get better performance than some of the other models. Same thing with Mistral Smol 24b. They had a series of charts that they put out, and it's like, how well did they perform? They even, I guess, benchmarked against Gemma-3 in here, and some of the other GPT-4o mini, Claude 3.5, Haiku, etc. Even models as small as 5.6 billion parameters are starting to top charts, and even in the multimodal scenario. So this is 5.4 multimodal, and they are arguing that they're better than some of the Gemini proprietary models with a very small footprint here. And finally, I even trained a 3 billion parameter model a couple of weeks ago, specifically on Rust programming. And this 3 billion parameter model got almost GPT-4o level performance on this specific task. And this specific task was writing Rust code that passes the build, passes the formatter, and passes unit tests. So that's like the 3 columns here. So I saw it firsthand. I'm like, you don't need huge models for some of these tasks. And the real reason I would argue that this is really popping up right now, or one of the reasons, is DeepSeek was a big moment for showing that labs outside of the big labs can do some of this work, but also just for like unlimited synthetic data that we can fine tune our own models on. Like, in the terms of service for the open AIs and the Anthropics of the world, like, you shouldn't be training on their data. Now with DeepSeek v3 and R1, you can generate like as much synthetic data you want for reasoning or for other specific tasks. And that's exactly what I did when I trained that Rust model. Was I just like grabbed a bunch of data from DeepSeek, and that's like a great jumping off point. And it's like, I kind of feel like there was a small language models, and then we got this era of huge ones, and I feel like it's going to cycle back down to like just what you need for the task, because now we can collect as much data as we want from the big ones and like make them work for our use case. And the amount of line of code that it takes to like run a supervised fine tune or RL is like under 100 lines. You just kind of need the data, and you need a GPU, and then you can fine tune these things pretty quickly. Yeah, so for so the question was, did I use any specific framework for the SFT or RL? I was just using the TRL library from the Transformers or the Hugging Face team. And they have a really nice SFT trainer. And then they also have a nice GRPO trainer, which I used for the RL experiments. Cool. So I would argue that like, that's all great, but none of it matters without your data and your criteria. And I stole this from the AI engineering summit that I went to last month. This was from the folks at OpenPipe, but I thought this was a really nice visual of like the trifecta that you want to look for in inference. And the first graph here is just the error rate. So all of these is lower is better. And so what they're doing here is showing, okay, what's the error rate of O3 mini and what's the error rate of GPT-4o on your specific task, and then drawing a line of like what the max acceptable error rate would be. The Then they have latency, which also lower is better. And so you can see like O3 mini makes less errors, but is much slower, right? So you're trying to balance like how accurate it is and how fast it is. And then the final one is just cost per 1,000 API calls. So this specific use case, I think they were processing like 500,000 documents a day. So both price and latency, well, throughput actually, were really important to them. And then they have like a higher bar for the error rate. They're like, we'll accept a little higher error rate if we hit these other two benchmarks. And I think that's like a really nice way of thinking about it. Once you get to that scale of, hey, we have real world data coming through. We know how many documents we have to process. We know what like a gold standard should look like. And we know how much we're willing to pay. So then they fine-tuned a Llama 3.1 8 billion parameter model to get under their desired lines on each one of those axes. So if you really know what data is coming in and out, and you really know your task, and you kind of draw these lines of what's acceptable, that really helps steer the process of using these small LLMs. So what I wanted to walk through today was doing that on Gemma-3 and Mistral 3.1, and I cooked up all of these evals today. So this will be the like live demo part of it where we'll be walking through these. So I'm not arguing that these evals are perfect, but they will be like pretty fun to walk through. So there's kind of two ways that you can do this within the Oxen platform. So I did all of this because it was just pretty easy to do it. And the first way is you can like pick a model and run it on your data given a prompt. And we have a bunch of different models supported in Oxen AI, but the first kind of task that we're going to be doing is this SimpleQA benchmark. This benchmark was released by OpenAI pretty recently. And what they did here was, it's like a bunch of Wikipedia style pub trivia questions, but ones that GPT-4 didn't get right. So like they kind of looked at all of, they took a bunch of Wikipedia pages, asked a bunch of questions to GPT-4 and like saw where it went wrong. And I think that's a super interesting benchmark because I think a lot of models kind of like grab their data from GPT-4. So if like GPT-4 can't do it, a lot of models probably can't do it. And so what this data looks like is you'll have a little metadata on like where they got the question from. So some Wikipedia articles or something like that, then the question, and then just like a single string answer that you have to reply. I also love this because this is like what we were doing at IBM Watson day in and day out. And it's fun to see questions like this kind of have a resurgence. And they're not like that crazy of questions, like who was the first recipient of the Knuth Prize? You'd expect like Google would be able to answer a lot of these, and it can. But the idea is like, can we encode these, or are these encoded into the weights of an LLM? And if you look at Mistral, I'm just gonna go straight here. Out of all of the benchmarks that they released, SimpleQA is like by far the worst. So I thought it would be a fun one to look at like how wrong these models get on here. Some of the other benchmarks, I would argue that like we're benchmark hacking. Maybe they like leaked into the training data, but it's super interesting to me that the models don't do great on this. Yeah, right. So even for other benchmarks, none of these models are getting over 50%. This one, I feel like MMLU and human eval have even been around a little longer. So like, I don't know. They have a lot of interesting charts to dive in here. And like, I think charts are like a great jumping off point, but I like just going line by line through the data to kind of look at this. So within Oxen, we kind of have this ability to, actually, I'll start from scratch so you guys can kind of see how it works. So you can come in here, and we have a suite of different models. So we could even do this real quick for like GPT-4o mini. And I'm going to grab the same prompt that I used here. So like you're an expert at answering trivia questions, answer the following question with the person, place or date that answers the question. And then I'm having the model just put the answer in XML tags. So it's like really easy to extract. And then if you don't know, just put I don't know. And some of the models know when they don't know, and some of them just love to take a stab at it. I'm going to pick the output column just to be response. I actually don't remember what I did in the other ones. But what's cool is you can run these prompts and kind of like iterate on your prompt a few times before you kick it off on the whole data set. And so this looks like it put the answer in answer tags, which is great. If I pick some other model, like let's do Llama 8B and run it again, you can see it might ramble a little more before answering the question or put like multiple answers in there. And so that's kind of like what the inputs and outputs are going to look like. So let's go back to GPT-4o because I actually didn't do a benchmark for this one. And kind of like Git and GitHub, you can just have branches of these things. So I'm going to put this into an eval GPT-4o branch and just call it like results.parquet marking 4o. And we'll run this and we can come back to this a little later, but you'll see it kind of like one by one goes through your data set and we'll be answering all of these. So one that's already been completed, I've done O3 mini, Gemma-3, 27B. So maybe we'll start with this one. And here's a good example of it kind of like rambling before it answers the question. So got this one right, got this one wrong. Sometimes dates, even like the formats you'll see are slightly different. So even if we were doing a direct string match, we might be counting those as wrong. And I bring this up because you'll see some of the numbers and you'll be like, oh my God, that's low. But you have to keep in mind there's like some direct string matching going on here. And so what I did from here was, that's one tool within Oxen. Another tool is just the ability to run arbitrary notebooks on your data. And so if you have like a Python notebook here, you can spin it up on some arbitrary hardware. We don't need much to do this specific task because this is going to be like grabbing a data frame, grabbing all of the outputs, extracting the answer, and then computing an accuracy. And so this was a old one that I had there. Let's look at this. Load this up a little bigger so we can see. So this is the raw data set here. I went through and just have like a regex to extract the answer, and then I lowercased them, stripped them, and compared them and put them into this is correct column here. You can see Gemma-3 got 6% accuracy on this, so pretty freaking low. I also just saved this out to a file that we could go look at line by line. So on this branch, this one, results, cool. So now we have the extracted answer in this column and then whether it's true or false. So I could say like, show me all the rows where true. We kind of have a text to SQL layer here that will go and write a SQL statement to find you all the true ones, which helps you kind of debug as you're going line by line here. And so looks like it's a variety of, yeah, it's got some people that it got right, some places. we can verify that that string matching was doing what we wanted to, but there were only 20 questions out of this whole data set that it got right. So let's look at some of the ones that it got wrong. And so obviously here, we don't have like any RAG or anything in there that can help extract the answer. We're just trying to see if it's like encoded in the model weights at all. And so you'll see like, this is a great hallucination. I recall reading about this prize before. The 2012 winner was Anish Kapoor. It was Yoko Ono. This one in Good Omens season 2 episode titled The Clue, what did Crowley turn Jobs' goats into instead of killing them? The correct answer was crow. It extracted ducks. So just a nice little debugging tool as you're going through and like seeing how well these models perform on your data. And so I did this for 3 models. It's my live demo warning.
Greg, if you have a second too, there was a question about the benefits of Parquet.
Oh, yeah, for sure. So you might have seen that I was using Parquet files instead of CSV files there. Oxen handles CSV, line delimited JSON, JSON, Parquet. Parquet is just like a really nice compressed representation of the data. It's like a columnar format that makes it really easy to do large SQL queries on and stuff like that. So it's just a little more compressed than like a CSV or a JSON file. Okay, so I kind of broke down these 3 models using that technique that I showed of there were like only 326 rows here, and how long did it take to run the whole eval? What was the cost of the eval, and how accurate were the models? And so I did this on Mistral Small 3, Gemma-3, and O3 Mini, because I wanted to just grab like whatever state of the art was. O3 Mini only got 10% on this task, to give you a sense. So even though it's called SimpleQA, it is not that simple. And then I just plugged those into Claude and told it to draw some charts for me. And so these are kind of like that same diagram we showed before, where we might want to draw our lines on like what axes are useful for us. You can see O3 Mini took the longest, cost the most, but like didn't give you that accurate of results compared to the other ones. So like if I'm picking out of these 3, probably Mistral, because it's the fastest, cheapest, and like gets reasonable accuracy on this task, even though it's like 6%, 7% isn't that high. So yeah, SimpleQA is hard. If you see SimpleQA in these benchmarks, game recognized game, it's not just the simple QA. And so then I wanted to do a little more practical one, because like we can all just go to Google and get those questions, those simple QA. You might have also seen like deep research, I think, is the highest performing model, because then it gets to go and do internet searches. But I wanted to do a more practical local model example. So I'll dive a little into what I did for this Rust programming benchmark, because I think it's pretty interesting. So the data set here, I made one called MBRP. There's a highly recognized data set called MBPP, which is mostly basic Python programming, but I didn't find one for Rust. So I made one and I called it MBRP. And so let me pull that up in another tab. We can take a look. Back on SimpleQA. Mostly basic Rust programming. Okay, so I have a little validation set here that we'll be going through. And the idea is that you have just like a prompt that's pretty specific. This is just like writing one function. So it's not like a general agent through my code, but it's like write a Rust function to find the minimum sum of factors given a number. And then you have the Rust code that should do that, and then you have a set of unit tests that it should pass. So that's kind of what this benchmark is. And I actually took the mostly basic Python programming questions and used an LLM to translate it into Rust. So instead of write a Python function, it says write a Rust function. And if there were any like Python specific lingo in the question itself, I actually have the prompt somewhere in here. Oh no, it's in my other playground. But I told it to not use any Pythonic like terminology. So what I did was I had this big ol' prompt here that said, you are a pragmatic Rust programmer who enjoys test-driven development, et cetera, et cetera. Your code needs to pass cargo build, pass cargo clippy. Don't add a main function. Try to like limit library usage because this is all just very simple tasks. As I was iterating, I noticed it was having a lot of errors on like basic type matching. So I was like, be careful with your types. And then I have it write out unit tests for the function that you just defined. The reason that I had it do this in the same prompt and not in like two separate steps was one, it would be hard to do this all today if I had it in two separate steps. And two, if you don't do it in the right order, like if you have all of these unit tests that have like a specific definition and type structure, and then you ask it to write the code without seeing the unit tests, like just give it the prompt. I got a lot of errors when it was like just on types or naming or something like that. And like in the real world, you're not going to have the unit tests yet. So I was like, okay, just generate both of these at the same time to make my life easier and to be a little more real world. The downside of that is you could imagine just writing tests that don't do anything or just are very simple tests like 1, 2, 3 or whatever. Going through some of the outputs, it didn't seem like it was hacking it at all. So that's kind of like what we're working with here. And so for this one, I actually spun up a notebook here, and this is a more interesting notebook to look at. But this one has the cargo build tools installed, and it goes through all of the LLM generated code, and it'll run cargo build, it'll run cargo clippy, and it'll run cargo test on here. And it needs matplotlib, which I didn't have pre-installed. So that'll just take a second here. Cool. And then I can basically give it a pointer to the Oxen repo, a pointer to the branch, and the input file that we want to run it on. And then we can just kick off this eval. And so this is on those 90 rows that we just saw. And you'll see it's like in the background running 3 build tools. So I kind of have this Rust tool class that runs cargo given a tool name. So it's like cargo build or cargo clippy or cargo test. And then I'm building up this result set of if that tool passed, capturing the standard error, capturing the standard out, which would also be like an interesting data flywheel to kick off, right? So like all the ones that it got wrong, we now have error messages for that we could potentially feed back in a subsequent round to see if it fixes it. So I'm collecting all of this data. I'm just using like a few regexes or splits to grab the Rust code and grab the tests. And then I'm populating this template that just has like, put the code here, put the tests here, and like a main function. And so this will take a minute to run, but at the end of this, what we get is an output that'll look like this. So it's how many times did the code pass the build? How many times did it pass the Clippy? Which if it doesn't pass the build, it's not going to pass the formatter. And then how many times did it pass the test? And so honestly, this Mistral 3.1 passed the build a decent amount of times. And I'd be curious to see out of these like 45% that it failed on, if you fed back in the error messages, like could you get that up to 80 or 90%? Did the same thing with Gemma-3, and it was slightly better than Mistral, at least on these 90 questions. So it got up to 57% instead of 54%, and then passed the build a few more times. And the final one, I was just comparing these to the 3 billion parameter model that I fine-tuned with reinforcement learning, and the 3 billion parameter model could even get better than those with some like reinforcement learning in the loop. So I think it's really interesting for these coding use cases where you have like verifiable outputs, that you can get even a model that's 3 billion parameters to do this task as well. In this case is GPT-4 or like models 10 times its size here. This was the single prompt. Yeah, this one. Yeah, so this one I used a technique called GRPO, where I had it generate 4 different solutions to each one of the prompts. And then for all the ones that it passed out of those solutions, you kind of like reinforce it to do more of that. And so that was the training loop in this case. Get this one better. And so let's see if that notebook finished. Okay, cool. So this was the graph that I just showed you, but kind of like finished in this notebook here. And then it saved the data to a data frame that we could look at. You can see this updated like 2 minutes ago. And it put the results in here. And so what this data set looks like, which is a little harder to see in data frame view, but this is like the code and the tests that the LLM generated together. So even in my prompt, I was like, hey, you can reason through the task in comments above the code. And then in the tests, kind of like describe in a comment what you're testing there. And then for debugging purposes, I put the whole program template here so I could look at it and even like put it into the compiler myself to make sure it was working. And then I'm putting any standard error from these tools. And then if the tests didn't pass, I'm also logging that in here. So you can see like this is an example of one of the ones that failed. And this is the type of thing that you could feed back in the second pass. So this is kind of me building up the data flywheel as I'm going along. Any questions on that? That makes sense?
I think I need to say that it is writing its own test.
Yes.
Like there's no test that comes with the question. Also.
Right. So in this case, it was writing the function and writing the tests, its own tests in the same pass. And yeah, like I kind of touched on before, the reason I had to do it in one is because I had all of those gold standard tests, but without giving it the tests in the prompt, it wouldn't match the function signature. So then it was failing all of those tests. Yeah. Yeah.
What's the scope stats, 90% result on? Because you were saying we limited the scope to a specific, like subset of parse problems, right? Like for a 3 billion parameter model, like how much bigger can you get with that scope?
Yeah, so the question was, with the scope of this 3 billion parameter model, how wide do you think it could go? Because this is like a very specific task of just writing a function and the unit tests. Haven't done too many experiments there yet, but what I want to do and what I think would be interesting to try next is in the DeepSeek paper, they kind of have this pipeline that they go through here. And so my training was actually just the RL reasoning training step. But when they did DeepSeek R1, they did like a supervised fine tune first to get it like general knowledge and like bootstrap it a little bit. And then they did reinforcement learning to get it better at reasoning. And then they did supervised fine tuning again. And then they did reinforcement learning again. And I feel like if you kind of put that small model in a loop of like, get it more knowledge, do RL, get it more knowledge, do RL, I'd be curious how far it could go, because I only did one of those steps. So don't have like a hard and fast answer for you, but I do think there's room to improve.
The focus, I guess, that you are referring to the Python test that you presented to us.
Yeah.
You could have also engaged them, or are you using them at some point because after you generate the function, because can we translate this to match this signature, transfer signature? Or?
You're saying, so since we have the Python tests,
This signature.
yeah. Yeah. And so he was asking from the original Python dataset, can you use that to bootstrap the Rust dataset? And I did do that. I just ended up not using them. It would be interesting to have like, it could be broken down into a couple steps where you like, you just put in the prompt and then you try to generate the function signature first and then do the other tasks separately so that you have that as at least like, we agreed on the function signature. Now we can go write each individual one. That'd be cool to try. Cool. Yeah.
The graph that you're trying to get is you're not overfitting, so it is like separate. You're not fitting the same data back into that.
Yeah, so two questions were the data flywheel aspect of this, of how we could improve it. And then are we sure that we're not overfitting just on the test data? Yeah, so for these ones, like it is purely just prompting. So I'm pretty sure that these models haven't seen at least my mostly basic Rust programming, which is cool. It's kind of like a brand new data set there. And then for the GRPO step or the reinforcement learning step, it's actually kind of hard for it to overfit to the benchmark because all I gave it was the list of prompts. And then from the list of prompts, I had it generate a bunch of different candidate answers. And then each one of those are verifiable because they have unit tests and they have like the builder or the build tools. So it's kind of just going through this loop of like generating a bunch of stuff, seeing what's right given the build tools, generating a bunch of stuff. So I could see it overfitting to just like the simplicity of the questions, but there's actually no, like in a supervised fine tune, there's no correct answers that I'm like directly feeding it back in. I'm just saying, did it pass the test and did it pass the build? So. Cool. And then the final thing that I wanted to go over was, these are great tasks, but like, what about multimodal? We kind of touched on this at the beginning, but there's this 5.4, 5.6 billion parameter model that's multimodal. And so I'll start by kicking off this notebook because it's actually going to take a second to load the model. And this one's probably the most fun to play with. And this one needs a little bit of a GPU behind it. And roughly when you're like calculating the size of a GPU that you need, this is a 5.6 billion parameter model. So at floating point 16, you can kind of just like double that number, and that's how many gigabytes of VRAM you need. So this model will take up 11 to 12 gigabytes of VRAM because it's 5.6 billion parameters. And so the first thing that I'm going to do is just like download the model, and then we'll go look at the data set while it's downloading and booting up. But this model is really cool because it can take in images or audio or text, and then put out text. And so we'll start with the benchmark. So this is a benchmark called OCR bench that I saw a lot of the models, or at least the 5.4 and Mistral using. And so what it looks like is like a bunch of screenshots of things and then questions about them. So you could imagine this being really cool for like a computer use agent that has to log into screens, or just like analyzing PDFs, or maybe like recognizing brands and images. There's a lot of different use cases here. And then the questions are like, what is wrong answer 2? So if we look at this image again, there's correct answer, wrong answer 1, and wrong answer 2, and we're trying to get the model to just pluck out that specific thing. So in this case, we have like the set of correct answers, and this was the model response just on. So it got that right. What's the name of the chef who received 4.5 stars on this recipe? So this one's kind of difficult because it has to put together multiple things in the image, like where are the chefs and what is 4.5 stars, and are they in the same card together? And this isn't even like a really easy name to extract, right? It's like a username. So I thought that was an interesting one. It nailed it, the response here. What application is being used to log in? It says login with Facebook at the top here. So Facebook. So for a 5.6 billion parameter model, I was pretty impressed with kind of the range of capabilities here. What is the sleep time? This is just like another picture of an app with the sleep time and awake time. Got that one right. And then one of the ones that it got wrong here was this phone number in this image, which is a pretty long phone number. And I even had to stare at it for a little bit to see what was exactly wrong between this string and this string here. But there is something wrong. 0, yeah, you guys see it there. And that was like right where the cursor was. So I wonder if it got messed up by that. But overall, I was like pretty impressed from this guy. And then, so I set up a little notebook here so that we could copy and paste image or audio URLs in and then ask questions of it. So try to find some stuff that's like definitely not in the training data. It's not showing it. So this is just your standard like Hugging Face model, auto model for causal LM, loading the 5.4 multimodal instruct. It downloaded it, loaded it into RAM. Like I said, it's just like 11 GBs or so. And then I have a regex to just replace like the image URLs with this custom token that they have in there. Same thing with audio URLs. And then there's a little bit of processing that you need to go through. And it was kind of annoying because you have to like either pass in images and audio, or just images or audio or just text. But luckily my little chatbot does all of that for us. So say hi, this is all running on this GPU. It doesn't have like the fancy just completing as we're going along. But I could grab, this is where it's going to get interesting, of the tab switching. Let's look at, I have a couple test images in here. Let's just do the notebook UI. I took like a screenshot of our notebook UI and we'll see what we can extract from here. So I'll copy the image address. And we're back. And we'll say, what is the company name? And then I'll just put, I actually haven't tried this one yet, so we'll see. The company name is Small LMs. So I think it just grabbed that from like here. Let's see. I actually don't remember what else is in that image. What is the prompt for a combo? Should have made it so you guys can see the image in here too, but start a conversation by typing a message below. So if we switch back to this one to look at the image, there we go. It extracted that from the screenshot. What's that? How many oh, that's a good one. That's a little harder of a question. So we're going to ask how many messages are there? Weird. Render. Fun. Putting our UI to the limit here. Good old page refresh. No messages yet. There we go. I also like a more real world use case would be like, say you had like a bunch of images and you wanted to extract brands from them or something like that. So I just have like a picture of a Starbucks mug here. So extract all the brands in the image. Starbucks, pretty cool. Yes. Yeah. I actually think we have a data set called ChartQA that I could grab something from. Should have cleaned it in one of these. It's this one. Okay, so this has a bunch of like charts like this. Might as well just go for this one. Copy image address. What do we want to ask? What is the highest? Right. The highest, is it selling? I don't know. Highest price drink. Okay, I like that. So this has like a couple steps of reasoning, I guess, that you'll have to do. Zero. Getting sassy with us. Did I extract that right address? Oh, you know what? You know what's going on here is I think my regex isn't doing capital letters here. So I don't know if it will. Yeah, actually it does. Okay, let's try that. No, it doesn't. Yeah, okay. Spoiled my script. Okay, the other, so it can do images. That's cool. It can also do audio files. So let me go grab an audio file. Actually, we can always come back to this notebook. So test images, data, audio. This is my new favorite test where I say, hi, my name's Greg Schoeninger, which is really hard to spell. And we're doing archive dives with Oxen AI. So archive dives is also really hard to spell, and Oxen AI is hard for LLMs.
My name is Greg Schoeninger, and this is Archive Dives with Oxen AI.
Okay, so that's the file that we're going to be working with. And we need this guy. Transcribe this audio file. Hi, so it was close. It got Oxen AI. That was the first time it's gotten Oxen AI. Archive dives. Some of the examples from the paper were like transcribe this audio and translate it to Spanish. It didn't do the translation. Maybe because I did the capital. That's... Not liking it. It did try to do it earlier. I wonder what my prompt was for that. It doesn't. No, it's just one by one. I'm not feeding the whole chat history here. Oh, good call. Good eye. Yeah, I did -O because I grabbed my curl command here. Okay. Good eye, Eric. That's just the URL. No, this is what I've seen before. Oxen UI. Yeah. So actually, that's Spanish for oxen. Yeah. No. Yeah. So anyways, you see how fast this thing is spinning up on a single GPU. I'll shout out base 10. I also got this like up and running on base 10, so you could have an API that hits it. Pretty cool that like we have these capabilities. And if you look at the PHY for multimodal, they were comparing it to GPT-4o Vision and Gemini Flash Vision, and it's just like right up there with those guys. So pretty impressive for a small model there. So yeah, hopefully that gave you like a good little framework to evaluate models. It was fun to look at the inputs and outputs and maybe inspired you to like, hey, we can build some of these things at home. And I think for privacy reasons, for just general fine-tunability, running locally and coding on an airplane, they're fun to play around with. And we also launched those notebooks literally today, and I was pretty impressed that we didn't have any errors as we went through. So give a round of applause to these guys. If you guys want, we're just giving 20 bucks of free credits for people to kick them around. And like I said, you can, from that drop down, you could pick an H100 if you want, and we just bill you by the second. So have fun trying out some models. All right, you want to kill the recording, Scott, and we can just do some general questions?